just in case I say something worth hearing. Let's turn that on. So 63%, notice not qualified, there's nothing else there. I mean, I could click on it. There's probably like a whole banana website and awesome and so forth, but whatever, let's just take the first piece of evidence we get. Now, again, does it make sense? You could question that. Now, that would not be something like yesterday that would kind of change over time, right? This would just be, well, let's go verify that. And again, this is what scientists do. As I said, I don't really consider this a very interesting question. I don't think, let's go check, we don't think that's right. Who cares? It's a banana. But would you agree at this point? I mean, number one, that kind of, I don't know, sounds good to me, right? It's not like you've ever thought about this question before. But let's just say, in the spirit of what we've been discussing, that we disagree with that. Again, do you understand that this question would be a percentage, not a mean? Does it make sense? I could ask another question about bananas, which would be like, what's the average weight of a banana? Like when you buy it at the store, there's little tiny ones sometimes, pretty big ones. So that would be like a mean related question that we'll start tackling tomorrow. But this particular question is naturally a percentage. There would not be any other way to kind of ask it. Of course, a person could kind of go on and say, what percentage of an apple is edible? What percentage of a strawberry is edible? And, you could kind of go on and maybe make some interesting conclusion with that. But let's just go with that and carry on. So let me share a screen here that I can write on. That's not how to do it. It should be too late for this now, but of course, again, this would be a potentially interesting question for a final project if you're like a banana person. So 10.2, first question. What percent of banana is edible? Thanks to Shelley for asking the right question. And my friends, we're going to do an experiment. Now, I want you to think about this big picture, because again, I think it makes a difference if you're touching, handling, and thinking about this in a little bit more detail. So you decide that you don't think so. Really? Let's find out. So I've got a scale here, so you can see this. Seemed like last time I did this, it didn't show up super well. Turn the light on, maybe that helps. That's probably reasonable. And again, I want you to think a little bit more big picture, because obviously, well, actually, I'm not going to say that because I want to know if you figure this out yourself. But this is not a simple experiment to perform if you decided to do this. But write that down. So notice the whole banana weighs 214.5, and you can't see it, but in the upper right-hand corner, there's a little G for grams. Actually, it just settled on 214.4. Now it's back to 214.5. I guess I'll go with 2.4. Now it's back to 4. Can't decide. Doesn't really matter. I'll just say 5. And of course, the easy way to find out what this would be to, well, I don't want to weigh the banana because it's my breakfast. And I'll have to touch that drug scale. If you ever need a scale, cops pick them up all the time, so you get a free one. But I have lots of drugs on it, so I don't want my banana peel on the drug scale, so on my banana. Now, what I want to know is, can you tell me the percentage? from what you see there. The peel we'll say is 65.6. So go back here. So what did we get? Yes, except for we are questioning this. We're questioning, that's our data is a percentage. And so we're questioning that percentage. So we're saying, really, it's 63%? I don't know. I have no idea. I would say you're doing it right. This is what it kind of feels like in real life. I would be willing to bet, even this far into the class. Some of you would 69. That sounds reasonable. So notice I weighed the peel, which isn't really what you want. You actually want the weight, which is why Shelley, I think, subtracted those two. I'm just catching up to your brilliant logic. So the banana actually weighs 148 grams because I didn't want to weigh it directly. So then we now have at least something intelligent to say about it. Notice that's our p hat value. So it'd be 148.9 divided by the entire weight of the banana, 214.5. Like, would you be able to sort all this out on a test? You know, if I asked you a question like this? Yeah, you are correct, 69%. Again, who cares about rounding? I'm going to go one more decimal place. Now, would you agree that that's, I don't know, you might say evidence with quotes around it that that's evidence that maybe 63% isn't true. However, what's wrong with our evidence thus far? Exactly. Thanks for reading my mind or thinking clearly. Notice this is not very strong evidence because we only weighed one banana. Like if you're going to do this, you got to weigh a whole bunch of them. And their average needs to be 69%. Does that make sense? Of course, you know, and we didn't look this up on the internet, but we could have said, what's the average weight or the average percent of a banana that's edible? It would have been nice if we not only found 63%, but as we've been studying in chapter 9, an error of 4%. In other words, they did not weigh all the bananas, right? So they must have done a sample. That's what statistics is. And they probably did a decent size sample because I'm sure there's banana nerds that, you know, make $1 million off bananas. So it would have been nice to know that there was like a 3% error in that study or a 4% error. If they said there was a 4% error, then, you know, we might say, oh, well, I guess it wouldn't be surprising that I got a number like 69% because 4% above that is 67. And now we're kind of in the ballpark, right? So there's certainly variation from study to study, but banana to banana, there's even more variation. And so again, we have to ask the question, is this just one sort of heavy banana? And of course, if you're a thinking person, you know, you might appreciate that this banana has a stem on it. And so, you know, are you going to be anal about exactly where to cut it off? And sometimes they're larger, sometimes they're smaller. You're just going to kind of take it from the place it comes from store, I mean, you do have to pay for it, right? So you can cut the top off, but you're not gonna be able to do that at the store. But just to, I don't know, make this a little bit more interesting, let's pretend this was the average for n equals 82. So we weighed 82 bananas. And again, I would just kind of ask you rhetorically to think for a second. What would you do if this was like your final project, or, you know, in the real world? What would you do to produce a percentage if you had 82 bananas instead of just one to produce this p hat number? Think about that for just a second, because I actually do want to ask you. Because that's not necessarily simple, and there's even maybe more than one way to do it. What would you do? Obviously, I'd weigh all the bananas. I'd do what I just did, except 82 times. But what would you do to get the average p hat value? Let's pick on Angela. What would you do, Angela? And I ask this because this isn't as easy as it sounds. Like, you do a book assignment question and you get it right, but you see how different it is in the real world. You just have nothing, like you got to invent it. What would you do, Tisha?
What you're saying, you weigh all the bananas and then you have to peel them, weigh all of the peels.
Yep.
Subtract the peel weight from the banana, the total banana weight, to get the weight of how much just the inner part of the banana is.
Yeah,
And
so
then
now you got,
divide that by the total weight.
you said that, what would you do with all of them though? Because basically that 148.9, you'd have a whole bunch of those now. You'd have 82 of those and they wouldn't all be 148.9.
Oh,
So
right,
what would you
add
do?
those all together,
Mm-hmm.
and then divide them by the number of bananas. Weight, and then subtract that from the mean of the total weights.
Yeah, except for what you said at the end, everything is exactly right. In other words, you'd have to find the mean weight of all the bananas. We have 148.9. We have to add them all up, divide by 82. And now we'd have an average weight. And then if I divided that, actually, maybe I wasn't thinking, I was thinking we'd have to divide by this number, but that's not even common, would it? That's not the same as every banana, right? Because that's what we just did a second ago. We took 148 divided by 215. Maybe I should have listened more carefully, because I was thinking we were going to add them all up, average them, and then divide by 214.5, but you can't do that because they didn't all weigh 214.5. So maybe you should say what you said again. Maybe you're right, and I just wasn't thinking.
So you're asking how I would run the study.
Well, how do you come up with this number if it's based on 82 bananas, not just one? How are you going to get an average for p hat instead of just we got one? And I thought you were on it. In other words, you got to weigh each banana and then weigh each peel, and, you know, get an actual weight for each banana. And so now you got 82 banana weights. Yeah, so I divide by 82. Now I have an average banana weight. But does it make sense? You'd also have to divide by, well, the average weight here too. It's like you'd have to average all the weights. Maybe that's what you said. Average all the weights and average all the banana weights and then divide those. Now you'd actually have an average. And so that'd be a lot more work. It'd be a little bit different. Tell me if you think this is true, but I think it might also work to get, I got this percentage for one banana right here. So then what if we just repeated that process 82 times and we had 82 percentages and then we added up the percentages and divided by 82? I think that would accomplish the same thing. Does that make sense?
Yeah.
So again, it's kind of funny, but that's very different than a book problem, which is again kind of why I would, if you have any way that isn't ridiculously painful to collect your own data, it makes you think a lot more deeply. And that's a real problem like this is kind of much harder. So and I kind of implied this in what I said, but because we went into this not knowing, we just questioned the established wisdom on the internet of 63%. We just questioned it and said that's worth checking, and we didn't have any idea if it was high or low. And so for that reason, we went into this as a two-tailed test. And so what we're looking for is evidence to reject the fact that the established hypothesis is that P is 63%. In other words, the proportion of the banana that's fruit is 63%. We want to challenge that hypothesis. We want to think it's wrong or it's changed or whatever. And so the question is, do we have enough evidence? And then I've got a set, what do we call that thing yesterday? I'm looking because I don't remember either. The critical value, or this, we got a significance level, which gives us the critical value. So, you know, how important is this to us? Is it really important? So we should make it 1%? Or is it, it's bananas, who cares? Let's make it something a little smaller. Let's make it 4%. And I'll put the language in there again, just since, and maybe you got started on this yesterday, but you sort of have to know these words, as I said, to be able to do the assignment. So can you answer that now? I think I've told you everything that was necessary. Again, we pretended that 69.4% came from N is 82, so it was a little stronger than just our one banana. And with respect to that significance level, it's important to understand this is a two-tailed test. And so your book, in the bigger questions, which is what your test will look like, it asks you for two things. So it's kind of good to be able to organize those. What's your critical value? And secondly, what's the test statistic? And those are both just the language of your book. Both of these are just z-scores. And we're going to compare them to see whether our test statistic is out in the tail. So let me just give you a second to think about that. I'd rather you actually, even if you're wrong, like you've worked on your project yesterday and you haven't thought about it that much, from yesterday's discussion, try to get this right, even if it's wrong. And then my point is whatever I say after that, we'll probably go in a little deeper, like if you make a mistake. Shelley.
Do you have to find these scores with two tails?
No, because after we did our experiment here, so at first we said we have no idea, but then after we did our little experiment, we got a higher answer, which means we'll be focused on the right side tail.
Oh.
We'll be looking at the right side tail, if that makes sense.
Even though, so we are questioning it, whether it's high or not?
No, because we started out,
Or are we questioning it too low?
we started out this is what I would say is a good scientist, which is we didn't just have an opinion. I think it's higher. Like we have no reason to even think that. We don't know. We just say, well, I don't know. Let's go check. That's interesting to me. I love bananas. They're my favorite fruit. I'm a monkey. So we care about this question. So we decided, I don't know, let's go check. I want to see if that's really true. I don't know if I believe it. I mean, isn't that kind of cool to think that you can actually answer these questions yourself now? Time consuming, right? You got to go buy a lot of bananas, but and peel every one of them.
Well, since the test came out higher,
So since it came out higher, after we decided we don't know, which makes it a two-tailed test, which means we have to split that 4% into both tails. Afterwards, we found out it was high, at least now we're thinking it's high. Then we're going to focus our attention on the right side because that's where it went. It went to the right side. The question is 69% far enough to the right of 63% to be in that tail where we can say, and that's not likely. I mean, it's 82 bananas have an average of 69%, and the right answer is actually 63. I don't think so. I think they screwed up, or I couldn't verify this, or maybe bananas have changed or whatever. So because this thing is two-tailed, you started this just disagreeing. And I noticed yesterday, just as some of you were looking into this homework assignment, you got to kind of read the question carefully to determine it, because they're not just going to tell you this is one-tailed or two-tailed. But the way I saw your assignment was worded was something like, the internet says 63%, and you think it's different. The word different is kind of the key word there. You don't think that's right. But the question could also be worded, you think it's lower, you think it's higher. So higher, lower, different, something like that. You got to look for that language. We said we don't know. So we're two-tailed, which means we have to take that 4% and split it. That's why it's important to identify a two-tailed test. So that means 2% is over here. That means 2% is over here. There's my 4% in the tails. And of course, that leaves 96% in the middle. Again, what does that mean? It means 96% of the studies that you would do would land inside that range. Only 4% would not. So there's basically a 4% chance that I'm still wrong. Whatever conclusion I make, there's still a 4% chance I'm wrong. We can't know for sure. There is no way to know for sure unless you check every banana. So, and this is what Shirley and I were talking about. Given that we got, our study showed it was higher, does it make sense we're basically expecting that it's going to be maybe over here? You know, the question is, did 69% make it out into that unusual place? Given that right now the established fact is the center of all of these studies would be 63%. The question is, did we get something a little higher than that or way higher than that? So I need this z-score. That's the critical value. That's the dividing line between I can reject, I can't reject the established fact. So that is inverse normal. To the left of that location is 98%. And so I get 2.05 for that. And you should say, oh, 2 standard deviations. Yeah, that's unusual. That's kind of way out there. So if it was out there, we would say that's unusual, right? That's the idea behind a hypothesis test. It would be unusual to land out there if the answer is actually 63%. So if we do land out there, we're going to say, I actually think I have enough evidence that 63% is not the right answer. The test statistic, though, is going to tell us, where do we land? Do we land in the evidence to reject or not? From yesterday, again, really the key is if I land here, I don't have evidence, just to write it in hieroglyphics and quickly. If I land here, then I do have evidence that 63% is not the right answer and it's actually higher. So you should be staring at your note sheet for this because it's ugly. But the z-score for, let's see, what do we call this yesterday? I was using kind of language and all of a sudden I can't remember what it was. Your book was calling this kind of the z0 score because that's the initial, that's kind of the established. Now we're going to go get our alternate hypothesis. So kind of the z, or maybe z based on alpha. Maybe that's z based on alpha. And now we're going to go get our alternate hypothesis. And so we said, what was that formula? Let me go and stare at your note sheet so you kind of feel good about this, because this isn't something you should memorize. But it says, take the established number. Do I have this right? No, I don't. Take the number that you just found, the p hat number, and subtract it from the established number. What that's going to tell us, of course, logically for a z-score is how much above the answer did we get? Well, we're 6.4% above the answer. We got an answer 6.4% higher. Now, that has no meaning unless you divide by the standard deviation. Is 6.4% a big jump? Well, if the standard deviation is 5, it's not. But if the standard deviation is 1, then it's a pretty big answer. So we're going to divide by the standard deviation. Stare at your note sheet carefully. Which one of the two P's do we use for the z-score? 63% or 69%? 63. We use the one that's true. Remember, we don't, ours is the kind of the questionable one. Ours is the one vying for attention. 63% is the established one. So that times it's what's left over from 1 divided by the size of your study. When you do that, you get 1.2. for, if you will, kind of the Z of our P hat answer. And so if I go look at the graph, then I think, oh, 1.2 is actually right there. So where am I? I'm in the no evidence area. With only 82 bananas, and you averaged all of those weights, that's only one standard deviation above the mean. So apparently the standard deviation must be like 6%, pretty high standard deviation. So you don't have evidence to say that it's wrong. Again, it's kind of a technicality. But it will really, the only way you can really speak correctly about this, if you're nerding out about it like the book does and so forth, is to say you either have evidence to reject what the internet said or you don't. We don't have enough evidence to reject the null hypothesis, the established hypothesis. Now, watch this just because it's interesting. Okay, how do I make this visible? So notice I typed in the whole expression that I just said all at once. Notice there's some parentheses in there. You don't have to do it all at once, but that's how I got 1.2. Of course, even though I know what I'm doing, it wouldn't be hard to kind of make a mistake here and accidentally do something wrong. So I'm kind of re-looking over what I said to make sure I got that right. But just out of curiosity, what would it take? What if you decided, yeah, I don't have enough evidence to kind of prove it in a court of law, but I still think I'm right. And so I'd like to get evidence. What could I do? What could I do to get evidence that it was indeed higher? What makes my case stronger? What can I do to make my case stronger? Way more bananas. Just for the fun of it, even though it won't be fun, let's do that. What if I still got 69%, but insert, I did that with 182 bananas? Do you notice we're going in the right direction to get above 2.05, but we're not there yet? That was a lot more work, but not enough.
So you can just like pick the amount until you.
Exactly. That's exactly right. Now remember, if you go weigh 182 bananas, maybe you won't get 69% again. Because remember, there's a chance, there's variation, right? Study to study. So if I did that first one with 82 bananas, they're all gone. I ate them all, threw up, I'm sick. Now I start over on a new day. I'm going to weigh a bunch more bananas. Remember, you could get 60% for the next batch. That's the whole concept of the last thing we're studying, is there's variation from study to study to study. That would, of course, be depressing if I was trying to prove to myself or somebody else that was really higher. I would have hoped I would have got a higher number again, maybe 68%, maybe even 70%, something like that. And notice, don't forget that 2.05 number was entirely based on me deciding I only wanted a 4% chance of being wrong. I could also fix this by saying, who cares about bananas? Let's make it an 8% chance we're wrong. So what am I going to do? Well, I'm just going to keep going until I get a number over 2.05. Let's try 282. There, I made it. And of course, I could keep playing with this. Notice that's not way past 2.05, but I could probably drop off 6 or 7 bananas and get it down there. But do you see what that's saying? It's saying if the same result I just got, 69%, was stronger because it was based on 282 bananas, then I actually would have evidence. So I'm trying to get you to understand the logic of this, the conceptual understanding of it, so that you could actually do something with this in the real world.
Do you think people actually like publish studies that maybe don't have much consistent evidence to argue a claim?
I would say yes, honestly, because, and I mentioned this a little bit the other day, but most like, I don't know if you know what the difference between a university and a college is. I was actually just listening to a podcast about this the other day. I never thought about it before. But he was saying a university, which is a four-year school, primarily exists to increase our knowledge of the world, the universe. So you have doctorates who are studying bananas or whatever weird thing they're studying, Venus flytraps. I mean, they study the weirdest tiny things. So you have somebody who's studying bananas, and their goal then would be to publish a paper telling us something that we didn't know before about bananas. And they're going to spend years on it. It's going to take a lot of time. And maybe they're even trying to get their doctorate, which is basically they came up with something and then other doctorates said, good job, that contributed to the world. So we're going to stamp doctorate on you, which I would think would feel pretty good. I mean, wouldn't you feel kind of cool if you had a doctorate degree? I would. So, you know, the last thing you want to do is spend 3 years studying bananas only to conclude, well, it actually is still 63% and I contributed nothing to the world. So, you know, is there some way I can spin the data to, you know, make my case, if you will? Is there something I can do? Hopefully intellectually honest. But if that was important, then I would say bananas wouldn't fall into that category. But if it was important, then some other scientist would try to replicate it. Like, wow, this is life-changing. You mean to treat anxiety, we shouldn't be medicating people anymore. We should be making them work out more or something like that. Because right now we're medicating for that a lot, more and more and so forth. And so you come out with a study that says, don't do that anymore. I mean, that would kind of feel like, that's pretty important. Is that really true? And then if somebody else replicates the study, then maybe we change how we behave as a society. If that other person can't replicate it, then you sort of go off as a quack, like, you know, you must have cheated, you must have, like, somebody else can't do 3 years of study on it, right? They just try to replicate what you did, which is why, true to form with your final project, you know, you have to say something about how you set the experiment up. If you're being honest, you have to say, well, I didn't tell you this, but I only weighed 6 bananas, and so my conclusions are really not that good. I mean, you have to kind of tell the truth about all that stuff. But yeah, this is pretty interesting. I mean, it's, and as you saw, we went to the internet a second ago, and the only thing we were able to ascertain was 63%, but we don't know anything about where it came from. So we wouldn't be able to replicate it. Also, I think I want to show this really quick too. So would you agree a second ago, we said we disagreed with this. And then what if you kind of did your little preliminary study here and you said, like you said, you don't know. And so then you did a little preliminary study like this. And now you said, I think it's higher, which would make it a one-tailed test. Do you understand that? So if it was a one-tailed test, how would the critical value have been different? What would you have done? The 4% would be entirely in the right tail, which means when you did your inverse normal calculation, you would have done it with 0.96. And notice now that went down to 175, 1.75, which means kind of the 182 banana thing would have worked. You see what I'm saying? Again, I just want you to have a sense of how in the real world, how you can kind of manipulate this stuff. And again, it isn't cheating. It's just, you gotta check with a sufficient number of bananas, but changing that confidence interval, in a sense, that confidence level number, changing that sort of changes the evidence. We don't have to be quite as sure now. So that's why it's important to be kind of one versus two-tailed test and so forth. But you can appreciate for an average person, even if you explain that, you know, if I explained that to you at the start of the term, I don't even know what you're talking about, right? You're just kind of relying on the person who knows to say there's statistically significant evidence that the answer is no longer 63%. And you're saying, well, you got a doctorate, so I guess you're right. I don't understand all that stuff. Let's do one more super fast. So take a look at this picture. This is, again, just something that's kind of fun. This is a rapid in California, one of the scariest rapids I've ever run. And so let's just pretend for a second that I'd run it a number of times. And let's say I was, I don't know, 40% of the time I could make it all the way through this rapid without flipping over. Because that's one of the fun things in kayaking. If you take on a challenging rapid, if you can make it through it without flipping over, you know, there's that sense of, yeah. So let's say I ran it a few times and I had kind of a 40% success rate of running this rapid. But then I said, okay, I'd like to get better. So the established number is 40%. And then I said, okay, I want to get better. So somebody who's better than me said, here's what you got to practice. Like you're always flipping to the right, or you're not feathering your blade right, whatever. You're leaning wrong, whatever. And so I practice. Does it make sense? Again, we're not questioning the initial stat because it was wrong. We're just saying I changed something. And the question is, am I better now? Did I get any better? I practiced for 2 months with something. And now I'm going to go run it again. And of course, you'd hope I would get something better than 40%. But the question is it statistically significant? It's kind of the language in the real world. Do I have evidence? So let's just quickly make up a question about that. What am I doing? That rapid's called Eraserhead. It's really shallow all the way through here. So if you flip over, your head would just get erased. I was terrified. It was only like a year and a half ago. So I'll say 2018, I had a 40% success rate. Then I practiced and I ran the rapid, let's say 16 more times. Now your gut reaction should be, it's going to be pretty hard to find evidence if you only ran it 16 times. A second ago, we peeled 82 bananas and it wasn't enough. And we sort of felt like we needed to peel 300 of them, right? So it sort of feels like already I'm probably not going to have evidence here. But I ran it 16 times and in the language of this question, I succeeded. I succeeded 8 times. Of course, 8 divided by 16 is a half. So I basically got 50%. And let's be nice to us and say the significance level is only 12%. Now I said this in words, but not in the question, but does it make sense? I practiced, and so I was assuming I would be better now. Like I'm assuming the percent will be higher. Does it make sense? That's a one-tailed test, even though I didn't write anything to that effect in the question. That's a one-tailed test. So quickly, I need to let you guys out of here, but quickly, could you, I'll just kind of make the note right here. This is right-tailed. The question is, do you have evidence? Can you produce the hypothesis test? The established fact is that my percent is 40, but my alternate hypothesis is, no, it's actually better now. Is it better now because it was a bad experiment? No, it's better now because I practiced. So I think it's higher. The question is, could those 16 tries just have kind of been a lucky day? Is there enough variation that that doesn't really prove it? 10% improvement seems like a pretty big improvement. But again, can you produce the critical value? And the test statistic? compare those two z-scores. Statistic, I guess I'm gonna rewrite that. Statistic. While you're thinking. Just gonna give you like one more minute. So I want to get you out of here. Okay, super quick. So because this is right-tailed, you assumed, or at least you hoped, you improved. So even though the established answer for all the times you've done this before was 40%, you think you've improved. But because you really wanted the answer to be yes to that, you were nice to yourself and said you're willing to accept a 12% error, which means this over here is 88%. So the question is, where do we land? Do we land in this critical region, which means there is evidence, or do we not? So of course you would say inverse norm, and the area to the left of that location that we're after, kind of that Z alpha score that we're trying to calculate right now, that'd be 88%. And because it's a Z score, the mean and the standard deviation are 1. And then your machine says the answer to that is 1.17. Notice that's a pretty low Z score. Well, that's because you picked 12%. You said, I'm fine with the 12% error. I just want good news, man. Tell me I improved. So awesome. Then you say, well, there's variation from study to study to study. If I go run this 16 more times, I'm probably not going to be upright 8 of them. Maybe it'll be 9 next time. Maybe it'll be 10. I mean, I'll probably get a different answer just out of randomness. And so you say, cool, and let's find the Z-score for that kind of p hat number. Well, our formula says, take the number you got, subtract the established number, divide by the standard deviation. Wow, that's a terrible square root sign. Divide by the standard deviation for percentages. There's a formula today for the standard deviation of a percent, but it's a different formula for means. We'll do that tomorrow. So established number times its complement, what's left over from 100, divided by, really small sample size. When you type that in, you get a disappointing 0.82. Which lands you, unfortunately, to the left. It's kind of like here. So the point is that could happen. With only 16 tries, it wouldn't be that weird for the established answer of 40% not to have changed. Now, am I happy that I did it 50%? Yeah. Does this mean I haven't improved? No, it just means there isn't evidence that you have. For sure. You can't say for sure with the 12% error. So there's not enough evidence. And I'll say yet to say I have improved. I'm saying that in English. In the book, it's going to say to reject the null hypothesis that your skill level is 40%. But in English, it would be like, there's not enough evidence yet. As we won't redo this, but of course I could go run it more times, right? If I change that 16 to a larger number and I still maintained my 50% success rate, then I could get evidence. Or I could loosen up that 12% requirement. I could make that even easier for myself. All right, my advice, be done with 10.2 before tomorrow. Unfortunately, the next 2 days, we're going to still be doing this. It's just that we're going to be doing this where the data is not a percent. Everything we've studied the last 2 days, the question of interest was a percent. Now the question of interest is going to be a mean. And then we'll be doing the same exact logic. It's just a slightly different formula. So that's the good thing. Conceptually, there's nothing else, just a different formula. All right, thanks for your patience. Get yourself out of here. And of course, stay after if you have any